Good day, welcome to my industrial project presentation. With all projects, a problem needs to be identified. I have identified for my project that South Africa is experiencing water supply and electricity supply problems throughout the country. And I have, through research, identified that the quantification of these services is not being done at domestic residences. And if we cannot quantify what we are using, we cannot know if we are reducing our water and electricity consumption. As prices increase, this becomes an ever-increasing problem for South African citizens. My main objectives of this project is to design and construct a utilities monitoring system that will use an Android device as the human-machine interface. That will be the information will be wirelessly transmitted from the device to the Android device, and that a website will be designed so that this information can be displayed on any internet browser. The envisioned benefits of this project are real-time measurable values of your water and power consumption. It will also allow you to monitor trends that you have for your usage, and also to monitor if any measures that you have implemented have been successful in reducing your power and water consumption. Also, there is the hope for expansion of this project to a greater national smart grid. If we move on to the block diagram of the project, we'll see the components. The heart of this project is the Arduino Uno. This is the controller for the system. It is monitoring the current and voltage through a current transformer and a voltage transformer. It is monitoring flow for the domestic flow through a flow meter, and real-time clock for timestamps for the monitored values. This is stored locally in the SD card reader with a green LED to state if the SD card has been initialized and if the system is working. It has two LEDs for high usage of power and water. This all communicates through to an Android device with a purpose-built app for this project. This communicates through the Bluetooth. This is two-way communication. The Android app requests information from the microcontroller, and also the microcontroller requests information from the Android app. The Android app will also be able to upload this information, and it will use the Android device's 3G or Wi-Fi connection to store this data in Google Sheets, which I'm using as a cloud storage, and also to generate the charts that we have over here as the final product. These charts will also be displayed on a website designed and built using the free wix.com service. These charts will be displayed on this website, plus also on the Android device. We have the flow chart with the sequence of the code and how the system operates. It is sampling every 1.2 seconds the sensor data, but it is compiling a complete consumption for a 10-minute period. And as we can see on our charts once again, these are for 10-minute periods. This is water usage. So this is total volume of water used for that 10-minute period. And on our power usage graph, this is watts per hour used in that 10-minute period. If we look up here, this is our circuit diagram. There is minimal additional components required, as most of the system is made up of modular units. The control transformer requires additional circuits for conditioning the signal so that the Arduino unit can read it, as it is reading the signal is coming through as a current sine wave. This needs to be converted to a voltage and also to be DC biased, so it is within the 0 to 5 volts that the Arduino unit can use. The additional resistors for the Bluetooth is to divide the voltage, so that because the output from the Arduino is in the 5 volt range, whereas the Bluetooth module can only accept 3.3 volts. This is now my completed project. I have housed it in a IP66 box with clear cover. I have used the 3.5mm headphone jack for the current transformer and an XLR connector for the flow switch. I have connected the voltage transformer directly to the incoming supply of the for the system, and I have connected a USB power supply circuit to the main supply to power the Arduino circuit. The system is set up that the LEDs are on the side. If we switch on the water, you can see that the LED for flow comes on. If we switch that off, it goes off. If we also switch on a kettle, the power light comes on. We now go into the app. We can connect to the Bluetooth HC05. I have on Google Sheets as well, I've set up a tip of the day that the controller of the system can be able to generate this and send it through to all the apps. I have also imported a set limits, so now I can set the limits. I can set the default set limits is 0 for flow and 1000 watts for power. We can put in whichever value we want. We put in 5 liters a minute for flow, and we can put in 300 watts for power, and we set it. This will now, as we're using more than 300 watts currently, the light is staying on. If we go and we put on the water, if we just turn it on, it won't come on, but as we turn it up, as we turn it up to that, we turn it down a little bit, it goes off, although it is still running. So we can set the limits of these LEDs, and we download. This has been downloaded. Now we can upload. As soon as the uploading message is gone, we know that the data has been sent to Google Sheets. To Google Sheets. If we go to Google Sheets here now, we can see that the values have been added. Water usage and power usage. And if we go to the Wix website, we'll see the old charts, but if we refresh, we will see the updated charts. This is the last 2 days worth of data that I have just uploaded. We can also now go to our Android app, select flow. We can see all the values there for the flow. This is what is stored on the phone. Last 2 days worth of values. There is the water usage graph that has now been imported in. Oh, sorry. So water usage graph that has been imported in. We can scroll and move it around. If we go to the power, you can see the power usage there, and the power usage graph there, and we can scroll across there. That is my project. Thank you for viewing this.